Right now, somewhere in the middle of the Pacific Ocean, there's a patch of water roughly the size of the entire United States. And it is running a fever. Not a small fever, a big one. The kind of fever that, in a person, would send you straight to the hospital. This patch of water does not look scary. If you flew over it in a plane, it would look just like every other stretch of blue ocean. No storm clouds, no warning signs, just water, sitting there, looking calm. But right now, that calm patch of water is already breaking things. It has already helped shut down one of the biggest fish harvests on planet Earth. It has already helped push parts of Europe past 40 degrees, hot enough that roads have buckled and train tracks have bent out of shape. And by the end of this year, scientists say it could change the weather for close to half the planet. Your morning commute, your grocery bill, even the food on your plate. This is not a movie. This is happening right now in 2026, and it has a name that sounds almost too gentle for what it can actually do. It is called El Niño. In Spanish, that means the little boy. Fishermen off the coast of South America gave it that name hundreds of years ago because it tends to show up close to Christmas time. A quiet little visitor, they thought. They had no idea what they had actually found. What those fishermen were noticing, without any way of knowing it, was the visible edge of the single largest weather event our planet is capable of producing all on its own. No storm, no volcano, and no single hurricane comes close to moving as much energy around the globe as this one slow, quiet shift in ocean temperature. But this year's visitor is not little. Weather agencies have already started calling it one of the strongest since record-keeping began back in 1950. That puts this event in a very small club. In more than 70 years of records, only a handful of El Niños have ever gotten this strong. To put that patch of ocean in perspective, you could fit dozens of countries inside an area that size and still have room left over. And unlike a single storm, which comes and goes in days, this patch of warm water sits there for months at a time, quietly pushing heat up into the sky the entire time. So here's the real question. How does a patch of warm water sitting in a part of the ocean most of us will never see in our whole lives end up deciding whether your city gets a flood, a drought, or a heat wave that breaks records? Stay with me, because by the end of this video, you are going to understand exactly how one patch of warm water can reach out and touch almost every corner of the globe. You will understand why fishing boats in Peru are sitting empty at the dock. You will understand why farmers in India spent weeks staring at a dry sky and then got buried in rain a week later. And you will understand why this year is different from every single El Niño that came before it, in a way that should genuinely worry you. But first, we need to figure out why this fever is so easy to miss, and why almost nobody saw it coming until it was already too late to stop. Before we go any further, if this is the kind of story that makes you want to know what is really going on with our planet, hit subscribe right now. We are following this one closely, week by week, as it unfolds in real time. Some of what happens later in this video is honestly hard to believe, and there is more still to come after this. You do not want to miss it. The ocean's secret switch. To understand how a patch of warm water can cause chaos on the other side of the world, you first need to understand how the ocean normally behaves, and the easiest way to picture it is like a giant bathtub that never quite sits still. Under normal conditions, strong winds blow across the surface of the Pacific Ocean, moving from east to west. Think of it like a giant fan blowing warm water from the coast of South America all the way over toward Asia and Australia. That wind is not gentle. It pushes so much warm water across the ocean that it actually piles up on the western side, like water sloshing to one end of a bathtub when you blow across the top of it. Here is the part most people never learn in school. When all that warm water gets pushed away from South America, something has to take its place. And what takes its place is cold water, rising up from deep down below. That cold water is packed with nutrients, like a bowl of soup that has been sitting on the stove for hours, all the good stuff settling and swirling together. Tiny creatures called plankton feast on those nutrients. Small fish feast on the plankton. Bigger fish feast on the small fish. It is a chain that feeds millions of people, all built on cold water rising up along one coastline. That is the normal state of the Pacific Ocean. Warm water piled up in the west, cold water rising in the east. It has worked this way for longer than anyone has been alive to remember. El Niño happens when that whole system breaks down. The winds that normally blow from east to west start to weaken. Sometimes they almost stop. And when that happens, all that warm water that was piled up on one side of the bathtub starts to slide back the other way, spreading out across the entire ocean. That warm water eventually settles right on top of the cold water near South America, like a warm blanket thrown over a cold floor. And once that blanket is in place, the cold water can no longer rise up to the surface. The nutrients stop flowing. The plankton disappear. The small fish leave to look for food somewhere else, and the big fish follow them. The whole chain, the one that took thousands of years to build, gets cut off almost overnight. That alone would be a sad story about fishing crews having a bad year, but it does not stop there. And the reason it does not stop there comes down to one simple thing. Heat rises. Warm ocean water does not just sit still and warm the air around it. It evaporates upward, and as it rises, it builds towering columns of clouds and storms, almost like a chimney made of weather. Wherever the warmest water in the whole Pacific Ocean happens to be sitting, that is where this giant chimney of rising air forms. And that chimney is not a small local thing. It is one of the most powerful engines on the entire planet. Here's why that matters so much. High up above our heads, there are fast rivers of wind that circle the entire planet. Weather forecasters use them to figure out where storms are going to travel next. Those wind rivers are anchored to where the biggest chimneys of rising heat happen to be sitting at any given moment. So when El Niño moves the warm water, it also moves the chimney. And when it moves the chimney, it moves those high up rivers of wind. And when those rivers of wind shift, they drag storms and rain and dry spells along with them, not just over the Pacific Ocean, but over India, over Africa, and all the way across the Atlantic. Think about how strange that really is. A patch of water sitting alone in the middle of an ocean, thousands of miles from any coastline, somehow reaches out and taps countries on the complete opposite side of the planet on the shoulder. It would be like someone turning up the heat in one room of a house and somehow causing the windows to fog up in a completely different house down the street. It sounds impossible, but that is exactly what a shifted column of rising heat can do once it drags the sky's steering currents along with it. That is the secret switch. A patch of warm water thousands of miles from anywhere flips it, and the weather on the other side of the world follows along. Worth knowing too, El Niño is not the only version of this switch. It actually has an opposite twin called La Niña, which happens when those winds blow even harder than usual instead of weakening, piling up even more warm water in the west and pulling up even colder water near South America. La Niña tends to flip many of these same regional effects in the opposite direction. Think of El Niño and La Niña as two settings on the exact same dial, one twisting the world's weather one way, and the other twisting it back the opposite way. Right now, the dial has swung hard toward the El Niño side, and it is still turning. So the real question scientists have been asking this year was never whether El Niño would show up. It shows up every few years, like clockwork. The real question was how far that warm water had already slid, and how fast it was still moving. You might be wondering how anyone can possibly measure something this big before it fully arrives. It is not guesswork. Scattered across the middle of the Pacific Ocean, there's a network of floating instruments, some anchored in place, others drifting freely, constantly checking the temperature of the water, both at the surface and far below it. Satellites circling high above the planet add another layer of detail, measuring the ocean's surface height from space, because warm water actually swells up and sits slightly higher than cold water does. Put all of that together, and scientists end up with something close to a live video feed of the ocean's temperature, updating constantly instead of relying on old records or rough guesses. To answer that, scientists watch one particular stretch of ocean the way a doctor watches a heart monitor beeping next to a hospital bed. And right now, that stretch of ocean is running more than 1 degree warmer than it should be, and it is still climbing. 1 degree does not sound like much. You might not even notice a 1 degree change in your own house, but water is stubborn. It takes an enormous amount of energy to heat it up, even a little. Heating a stretch of ocean roughly the size of the United States by a full degree means storing an amount of heat energy that is genuinely hard to picture in your head. Scientists who study this have compared the extra heat stored in an event like this to the energy of hundreds of thousands of small bombs going off, except instead of exploding all at once, that energy leaks slowly back out into our sky over the course of many months. That slow leak is exactly what ends up rearranging weather patterns across the entire globe. But the number that actually convinced forecasters something big was happening was not a temperature at all. It was something they saw in the sky. Weather agencies noticed that thunderstorms had started firing up over a totally different stretch of ocean than usual, while the storms over Indonesia, which are normally reliable, started dying down. That told them the giant chimney of rising heat had physically packed up and moved. That is not a guess. That is not a prediction on a computer model. That is something you can actually watch happen with your own eyes on a satellite picture. And that is exactly why, in the middle of 2026, weather agencies stopped calling this a possibility and started calling it official. They now expect this El Niño to grow into one of the strongest ever measured by the time we reach winter. Out of more than 70 years of record keeping, only a small handful of events have ever reached this level of strength. Here is where it gets interesting, because the first place this always shows up is the coastline the Pacific Ocean actually touches. And it has already begun. The dominoes start falling. It helps to understand why fish care so much about water temperature in the first place. Cold water holds far more oxygen than warm water does, almost like how a cold soda can hold its fizz much better than a warm one, which goes flat fast. Fish need that oxygen to breathe, and the tiny creatures they eat need cold, nutrient-rich water just to survive at all. So when warm water spreads in and pushes the cold water down deep, it is not just uncomfortable for fish. It removes the very air they breathe and the food they depend on, all at the same time. Off the coast of Peru sits the single largest fish harvest on the entire planet. Most people have never heard of it, yet almost everyone has eaten something connected to it without even realizing it. The small silvery fish caught there get ground down into feed that is shipped around the world to raise farmed salmon, chickens, and pigs. If you have eaten farmed fish or chicken recently, there is a good chance this tiny fishery played some small part in it. That fishery depends completely on the cold, nutrient-rich water that rises along the coast. So when El Niño arrives and that warm blanket settles over the top, the fish do not just have a bad week. They vanish, some die off, others swim down deep, searching for whatever cold water is left, sometimes diving over 100 meters below the surface just to survive. Watch how fast this actually played out this year. Fishing officials in Peru set this season's catch limit at the lowest level in 10 years, more than a third lower than what they allowed last year. That was already a warning sign. But it got worse. By early summer, boats had only managed to catch about a quarter of even that reduced limit, and more than half of everything they did manage to pull in were baby fish, too young to have had a chance to reproduce yet. Think of it like picking every apple off a tree while they are still small and green, before any of them had the chance to grow, ripen, and drop new seeds for next year's crop. You get a small harvest today, but you have wiped out most of tomorrow's harvest at the very same time. That is not just losing this year's catch. That is losing next year's catch, too, before it even had a chance to begin. The situation got so serious that officials shut the fishing season down entirely to try to protect whatever fish were left. One tiny patch of warm ocean water and an entire industry that feeds animals across dozens of countries got put on pause. Picture what that actually means for the people involved. Thousands of fishing boats tied up at the dock day after day, going nowhere. Crews who make their living from the sea suddenly earning nothing at all. Small businesses that repair nets, sell fuel, or process the catch, all watching their income disappear along with the fish. This single fishery normally supplies roughly a fifth of the entire world's supply of the ground-up feed used to raise farmed fish and livestock. So when it shrinks this fast, the ripple does not stay in Peru. It quietly raises costs further up the chain, all the way to farms raising salmon and chickens on the other side of the planet, most of whom have never even heard the word El Niño. Picture a small fishing town along that coastline, one of hundreds dotted along Peru's shore. Every morning, boats normally head out before sunrise and come back loaded with silver fish, enough to keep the whole town's economy turning, from the boat crews to the truck drivers to the workers at the processing plants. Now picture that same town during a season like this one. Boats tied up at the dock, ropes going slack in the water, engines sitting cold. Workers who normally sort and process fish standing around with nothing to sort. A whole local economy, built around a resource nobody could see running low from land, quietly grinding to a stop. Strangely, not everyone loses when the ocean shifts like this. Thousands of miles north, off the coast of Southern California, warmer water pushed in by this same El Niño has pulled in schools of tuna that normally stay much further south. Recreational and commercial fishing crews there have reported some of the best months of tuna fishing they have seen in years. It is a small reminder that El Niño does not simply destroy everything it touches. It moves things around, taking abundance away from one coastline and handing an unexpected gift to another, almost at random. And this was not even the first time. A milder version of the same event a few years earlier already forced Peru to cancel one entire fishing season completely, costing well over $1 billion in lost exports and leaving tens of thousands of fishing families without income for months. This year's version is shaping up to be stronger than that one, which is exactly why officials moved so fast to shut things down early this time, rather than waiting to see how bad it might get. Now here is where the next domino falls, and this one is even bigger, because it affects roughly 1 out of every 5 people alive on Earth today. India's yearly rainy season and El Niño have a long and complicated history together, and it is almost never a good one. When that giant chimney of rising heat drifts away from its usual spot near Indonesia, the winds that normally carry moisture onto Indian farmland weaken right along with it. Weather forecasters in India saw this coming and actually lowered their rainfall expectations before the season had even properly started. What actually happened was worse than even that lowered forecast. By the end of June, India had received nearly 40% less rain than usual, one of the driest Junes the country had measured in more than a decade. That is not a slow, boring month of rain. For millions of farmers, that is a season teetering on the edge of disaster. And then, just as everyone was bracing for the worst, the sky flipped completely. In the very first days of July, a string of powerful storm systems rolled in, one after another, and the rain came roaring back so hard that flood warnings and landslide alerts went out across huge parts of the country. If you only heard about one half of that story, the drought or the flood, you actually heard the wrong version of what happened. Because this is exactly the pattern El Niño tends to create in India. It rarely just switches the rain off for good. Instead, it makes the rain lurch back and forth, long dry stretches followed by sudden, violent bursts, and then dry again. And here is the cruel part for a farmer standing in a field. The total amount of rain across the whole season barely matters if it falls in the wrong week. Rain that shows up too late does not save a wilting crop. It drowns it, and then leaves it to bake in the sun that follows right behind the storm. There was one more piece of bad luck working against India this year. Out in the Indian Ocean, there is a separate weather pattern that can sometimes fight back against El Niño and drag extra moisture in anyway. In past years, that pattern has actually rescued the monsoon season when El Niño tried to ruin it. This year, that backup pattern sat completely still, doing nothing at all. There was no safety net. For the roughly 1.5 billion people who live in India, this is not just a weather story on the news. Farming families plan their entire year around when the rain is supposed to arrive. Seeds get planted based on a calendar built from decades of rainfall patterns. When that calendar suddenly stops working, when the rain refuses to show up on time and then dumps weeks' worth of water in a single week instead, crops that were counting on a slow, steady soak get flooded out just as they were starting to recover from being too dry. Rivers that had barely been trickling along suddenly rose fast enough to trigger landslide warnings in hilly areas. Whole communities went from praying for rain to bracing for floods within the space of about a week. 2 dominoes down already, one fishery and one entire country's food supply thrown into chaos, and El Niño had not even fully strengthened yet. Here is where the story takes a strange turn, though, because the very next headline, everyone connected to El Niño actually had almost nothing to do with it at all. The twist nobody expected. In the summer of 2026, Western Europe lived through something it had never experienced before. France recorded its hottest day in the country's entire history. Germany broke its own national heat record. And in Barcelona, the thermometer hit a temperature so extreme it broke a record that had stood since the observatory started measuring heat more than 100 years earlier. Thousands of heat-related deaths were estimated across the continent that summer. Naturally, the story practically wrote itself. A record-breaking Pacific Ocean and a record-breaking European summer happening in the exact same year. It seemed obvious they had to be connected, except they were not. When scientists actually ran the numbers to check whether El Niño had caused Europe's heat wave, the answer came back clean. El Niño played no meaningful role in it at all. Europe's extreme heat came from something else entirely. A giant dome of high pressure that trapped hot air in place over a continent that happens to be warming faster than almost anywhere else on Earth. So why bring it up at all if it was not even connected? Because it reveals the single most important thing to understand about El Niño's true danger this year. El Niño's biggest effects on the northern half of the planet do not usually show up in the middle of summer. They show up later, in autumn, in winter, and often stretch into the year that follows. This event had only just been officially confirmed a few weeks before Europe's heat wave struck. In other words, Europe's brutal summer was not caused by El Niño. It was simply the hot, cracked ground that El Niño was about to be stacked directly on top of. And that is the real twist. Every single El Niño before this one in recorded history showed up on a cooler planet than the one we live on right now. This one is arriving right after the planet just finished its warmest stretch of years ever measured. El Niño does not create heat out of nothing. What it does is release heat. The ocean has been quietly storing up for years, dumping it back into the sky all at once. That process reliably pushes global temperatures even higher than they already were. Think of it like this. If the planet's temperature was already a pot of water, sitting just below boiling, El Niño is the moment someone turns the burner up higher. The water was already hot. Now it is about to boil over. You can also think of the ocean like a giant battery. For years at a time, between big events like this one, the ocean quietly charges up, soaking in extra heat and storing it far below the surface where nobody can see it happening. El Niño is the moment that battery gets unplugged from the wall and switched over to power everything at once. All that slowly stored heat comes rushing back out into the atmosphere in the span of months rather than years, which is exactly why the effects can feel so sudden even though the charging up happened slowly and quietly the whole time. That is why this event is genuinely different from the 5 other giant El Niño scientists have recorded since 1950, and possibly different from 2 more suspected far earlier, all the way back in the late 1800s, long before anyone had the tools to properly measure them. Every one of those earlier events happened on a cooler starting point. This one does not have that cushion. Whatever heat El Niño adds this time gets piled on top of a planet that is already running hotter than it has ever run before in the modern record. Think about the difference between turning on a space heater in a cold garage and turning on that same space heater in a room that is already stuffy and warm from a summer afternoon. The heater puts out the exact same amount of heat either way, but the room that started out warmer ends up feeling far more unbearable, far faster. That is roughly the situation the planet is walking into right now. The last giant El Niños in history all switched their space heater on inside a cooler room. This one is switching on inside a room that has already been baking for 11 straight years. What does that actually mean in practice? It means that when this event fully releases its stored heat later this year, the world is very likely to see its warmest year ever measured, breaking a record that has usually only stood for a handful of years at a time before getting broken again. It means oceans that are already unusually warm could climb even higher, stressing coral reefs that depend on a fairly narrow temperature range to survive. It means mountain glaciers already shrinking year after year could lose even more ground than usual. None of these things happen because of one single dramatic moment. They happen quietly, in the background, while most people are focused on the more obvious headlines about floods and fires. There's another way to think about just how rare this is. Since weather agencies started keeping careful records back in 1950, there have only been a small handful of El Niños powerful enough to earn the label super, or very strong. Most years, if El Niño shows up at all, it is a mild, forgettable version that barely makes the news. The kind of event building right now only comes along a few times in an entire human lifetime, which is exactly why scientists are watching it so closely, and why the comparisons people keep making are almost always to the biggest, most disruptive events in the historical record, not to an ordinary year. You might be thinking, weather changes every single year anyway, so why does this one particular shift matter so much more than usual? Here's the difference. Normal year to year, weather is like small waves rocking a boat up and down, mostly canceling each other out over time. El Niño is not a small wave. It is closer to the tide itself, pulling out far further than usual, then slamming back in far harder than usual, all across the entire ocean at once. It does not just add a little randomness to the weather, it tilts the odds strongly towards specific outcomes across huge parts of the planet at the same time, which is exactly why so many different countries end up dealing with unusual weather during the very same stretch of months. Here is where the story stops being about one ocean or one country, because once that giant chimney of heat properly settles into place, it does not just affect Peru or India. It reaches almost every continent on Earth, and the effects are not the same everywhere. In some places, El Niño brings floods. In others, it brings the exact opposite. And figuring out which side of that line you happen to live on turns out to matter quite a lot. The ripple reaches you. Let's start close to home in North America, where the effects of El Niño depend heavily on exactly where you live, and where most of the impact does not fully show up until winter arrives. Across the southern United States, from California, all the way through Texas and down into Florida, El Niño typically brings wetter and cooler conditions, as storm after storm gets dragged across the region by those shifted high sky winds. Instead of one big storm passing through and moving on, this pattern tends to line up storm systems almost like cars in a traffic jam, each one arriving before the ground has fully dried out from the last one. For a drought-stressed corner of the country like the Southwest, that extra rain is mostly welcome news, refilling reservoirs that have been running low for years. For low-lying areas prone to flooding, though, it can mean the opposite kind of trouble, with soaked ground that simply cannot soak up any more water before the next storm arrives. Head further north, though, and the pattern flips completely. The Pacific Northwest and the northern Rocky Mountains usually turn warmer and drier during El Niño years, with noticeably thinner mountain snow. That thin layer of snow matters far more than it sounds like it should. Picture mountain snow as a giant savings account of water, slowly built up all winter long, then withdrawn a little bit at a time through spring and summer to feed rivers, farms, and reservoirs. When El Niño keeps that savings account thin, there is simply less water left to spend by the time the hottest, driest months of summer roll around. Rivers run lower, soil dries out faster, and the wildfire season that follows tends to stretch on for weeks longer than usual. The upper Midwest usually gets off relatively easy, seeing a milder winter than normal, several degrees warmer on average, without the extreme swings hitting other regions. Up in Canada, the same split holds true. The western provinces tend to run warmer and drier, raising the risk of drought and wildfire across the prairies and out toward the west coast. The further east you travel across the country, the weaker that effect becomes, fading out almost entirely by the time you reach the Atlantic coastline. Now travel across the globe to East Africa, to countries like Kenya, Somalia, and Ethiopia. Here, El Niño usually brings the opposite problem, far more rain than normal. That might sound like good news for a region that often struggles with drought until you look at what that actually looks like when it arrives. Rain that falls on hard, dry, cracked ground does not soak in gently the way it would on softer soil. It runs straight off, filling rivers faster than they can handle and swallowing whole villages built along their banks. A previous El Niño, one that was not even close to this strong, triggered devastating floods across that same region and forced hundreds of thousands of people from their homes, washing away roads, farmland, and, in some cases, entire neighborhoods. Back in South America, the trouble does not stop at Peru's coastline. The Amazon rainforest faces a serious risk of drought and extreme heat during El Niño years, which is especially dangerous because large sections of the forest are already worn down and weakened from years of clearing and damage. A rainforest is supposed to be too wet to burn, But strip away enough of the trees at the edges and dry out what is left during a strong El Niño, and you get something that should sound impossible: a literal rainforest catching fire. That already happened during one recent fire season, and a strong El Niño layered directly on top of an already stressed forest raises the risk of it happening again, possibly even worse. Further south, though, in Argentina, Uruguay, and southern Brazil, the pattern reverses completely, usually bringing heavier than normal rainfall and a higher risk of flooding in low-lying towns and farmland, the exact opposite problem happening just a few thousand miles away on the same continent. Over in Southeast Asia, in countries like Indonesia and the Philippines, the story flips back toward drought once again. Remember that giant chimney of rising storms that normally sits right over that part of the world. During El Niño, that chimney packs up and moves east, taking its rain along with it. Rivers used for both drinking water and farming can run unusually low, and crops like rice, palm oil, and coffee, grown across huge areas of that region, can come up short. That is part of why a strong El Niño year sometimes shows up later as a slightly higher price tag on things like your morning cup of coffee or a bar of chocolate, long after the actual weather event has faded from the news. Then there's Australia, which might be the clearest example of all. El Niño and Australian weather are tightly linked, almost like two ends of the same seesaw. All that warm water sliding east across the Pacific Ocean is warm water sliding directly away from Australia's coastline, taking much of its usual rainfall along with it. That typically means a hotter, drier spring and summer across the eastern half of the country, shrinking water supplies, stressing farmland, and stretching an already dangerous wildfire season even longer. Australians have lived through this pattern before, and the years it has shown up strongest have produced some of the worst bushfire seasons the country has ever recorded. Here is one more twist that surprises almost everyone the first time they hear it. A strong El Niño actually tends to make the Atlantic hurricane season quieter, not louder. When the Pacific Ocean heats up this dramatically, it changes wind patterns high above the Atlantic and Caribbean in a way that creates strong gusts at high altitude. A hurricane needs calm, steady conditions to grow, the same way a tall tower of building blocks needs a steady table underneath it to stay standing. Those high-altitude gusts act like someone constantly bumping the table, knocking developing storms apart before they ever get tall enough to become dangerous. That is part of why forecasters lowered their expectations for the total number of named Atlantic storms this year, predicting a season with noticeably fewer storms than a typical year would bring. But the ocean does not hand out breaks for free. While the Atlantic calms down, the eastern Pacific Ocean, off the coast of Mexico and Central America, gets the opposite treatment. Warmer water there and calmer high-altitude winds create nearly perfect, steady table conditions for storms to form and grow strong. So while one ocean quiets down and the other heats up, and whether that trade works out in your favor depends entirely on which coastline you happen to call home. A family in Florida might spend an unusually calm summer watching the tropics. A family on Mexico's Pacific coast, at the very same time, might be watching storm after storm line up off their own shore. Put all of these pieces together, the empty fishing boats in Peru, the whiplash monsoon in India, the record heat baking Europe, the floods threatening East Africa, the fire risk stalking the Amazon in Australia, and the shifting hurricane risk across two different oceans. And you start to see just how far one warm patch of water can reach. Remember that grocery bill we mentioned back at the start of this video? This is exactly where it connects. Fewer fish caught off Peru means feed for farmed animals gets more expensive. A stalled harvest in India ripples into the price of rice, spices, and cotton sold around the world. A stressed farm season in Australia nudges up the price of wheat. None of these things happen in a bubble. They all eventually land on a shelf in a grocery store somewhere, including possibly one near you. Here is the part that should genuinely change how you think about all of this. Every one of the 5 or possibly 7 giant El Niños in recorded history arrived without any warning at all. The people living through those earlier events had no satellites, no ocean sensors, and no way to see any of this coming until the floods or the droughts had already arrived on their doorstep. Back in the late 1800s, when 2 of the strongest suspected events in history are believed to have struck, entire regions were caught completely off guard. Farmers watched their crops fail with absolutely no explanation. Fishing communities watched their entire livelihood disappear overnight with no warning at all about why. Nobody connected any of it to a patch of warm water sitting thousands of miles away because nobody even knew that patch of warm water existed. This time is different. Scientists spotted the warm water building weeks in advance. They watched the storm shift over the ocean in real time on satellite images. Governments in India updated emergency plans for hundreds of districts before the rain even faltered. Fishing crews in Peru pulled their boats back before the season completely collapsed. For the very first time in human history, we get to watch this entire chain of events unfold link by link, with enough warning to actually prepare for what comes next, instead of simply reacting once it is already too late. That is genuinely remarkable when you stop and think about it. The ocean is not doing anything strange or unheard of. It has done the same thing many times before, long before any of us were born. The only thing that has changed is that, for the first time ever, we get to see it coming, days and weeks ahead of time, on a chart that updates constantly instead of finding out only after the damage is already done. So here's the question worth sitting with. As this El Niño keeps strengthening through the rest of 2026 and its effects finally reach the northern half of the planet through autumn and winter, what is it going to look like where you live? A stronger storm season, stacking up one system after another along the coast? A drier winter than usual, with rivers running lower and lower as the months drag on? Or maybe a strangely mild one, warm enough that it barely feels like winter at all, because somewhere out there, in your own corner of the map, this giant, slow-moving ocean event is very likely already quietly rearranging your weather too, whether you have noticed it yet or not. It has been building for months. It is still building right now while you watch this, and by the time it finally peaks this coming winter, almost nowhere on Earth will be completely untouched by it. If this video helped connect the dots for you, tap that like button and make sure you are subscribed with notifications turned on, because this story is still moving fast, and we will be tracking exactly what happens next as El Niño keeps building through the rest of the year. Before you go, tell us in the comments what the weather has actually been like where you live this year. Has it felt strange, too dry, too wet, unusually hot, or oddly mild? Between everyone watching this video, you probably cover more of this planet than any single weather report ever could. And if you want to see something just as strange happening far beyond our own planet, check out our recent video on the mysterious shaking happening deep underground on Mars. It is right on your screen. See you in the next one.